Welcome to our ERCI Leader 2030 webinar, The Role of Circular Economy in the Railway Sector. This is a joint ERCI Leader 2030 webinar. You will learn about the role of modern materials in the rail sector, focusing on innovative approaches to sustainability and performance. Being co-promoted with the Leader 2030 project, coordinated by ERCI and funded by the Europe's Rail Program, the event will offer you food or for thought to consider modern materials also as a way to reduce risks of materials scarcity in rail supplies, with special attention to those needed for rail innovations. I'm Lutz Hübner from the Cluster Transport, Mobility and Logistics in Berlin and Brandenburg. We are one of the members of the European Railway Clusters Initiative. And as you can see from this slide, we are in total 18 railway clusters, which are covering 17 European countries. ERCI is founded in 2010, and since 2022, it is a legal entity. ERCI represents over 3,600 enterprises, including over 2,300 small, medium-sized enterprises, as well as universities, research institutions, education institutions, incubators, accelerators, and so on. Yeah, talking about the services of ERCI, mainly to the majority of the members of the ERCI clusters, which are small and medium-sized enterprises. There is to mention the partner matchmaking in research and development activities, exploring new market opportunities also outside the own region within Europe, but also outside Europe, enhancing the visibility on international level, and discussing innovative topics which may have an impact to the development of the future rail system, like cybersecurity, multimodal and logistics, green and sustainable mobility, human factors, and so on. Yeah, ERCI is also giving some networking opportunities, for instance, due to one of the webinar series, and this is one webinar of the webinar series. Normally we have at least one webinar in 1 month. We are also preparing and conducting workshops, networking events. We are present at fairs and organizing business clubs. The yearly event of ERCI are the annual ERCI Innovation Awards. This is a competition where every member cluster can nominate up to 3 applications to the European contest, and the next awarding ceremony will take place in 2025 during the Expo Ferroviaria in Milano. Yeah, these are the contacts where you can reach ERCI. For sure, we are present at social media. We have our web presence, and for sure, we have also an email address. You find all this information also in the chat. Now I will hand over, because it is a joint webinar with the Leader 2030 project, to Guido Ancarani. He is the operations director of ERCI, and he will tell you some words about the first European project which is coordinated by ERCI itself. Guido, the floor is yours.
Thank you, Lutz. Yes, I would say some words about this very interesting project, which is based on the fact that we would like to help Europe's rail to understand how the railway sector could be autonomous in delivering Europe's rail research and development project, because it's good to have some development, but we have also to reach TRL9 at the end of the day. which means around 2030, be able to manufacture those research and development projects. This is one of the aim of Leader 2030, being able to go over the disruption that we have faced up to now in the past and try to avoid to have the same history in the future, not repeating some mistakes, so anticipating some needs of resilience. So this is a way with this slide to present the question. If we take a pencil, we know, we can see from the right-hand side of the slide, the indication that some materials are coming from 10 different countries. This is just a simple example, and you can imagine that a railway system, is it infrastructure, signaling, or rolling stock, will have some more problems and more countries from which the components, the raw material and the components will come from. But on the same time, we have also to consider that there are some difficulties, or there will be some difficulties in the European rail value chain because of several aspects which are around us. Geopolitical factors, you can imagine what I'm referring to, or the climate change that we are facing in this period, and unfortunately also maybe in the near future. So this is not the only reason why, but we have also to consider that railway will have some competition with other sectors, and those who are like military or aeronautics, aviation, or other sector will need maybe the same raw material, we need the same electronic components. Who will be the one who can use them as a first user? This is a little bit the question. So in order to face this, we have proposed to Europe's Rail a project, which is Leader 2030, coordinated by ERCI, but using the 18, now 18, in this slide we were still 16, cluster on the field, knowing which are the problem coming from the rail supply chain locally, and be able to face those problems and try to find the solution in terms of disruption and try to avoid them. So the composition of this project is with 4 partners, ERCI, as I've said, but also Railenium, the technological center in France, JKZ, which is the cluster in Saxony, the cluster of mining, and Technopark Istanbul from Istanbul, able to help us in defining the needs from the other sectors in order to understand where and how rail is positioned in this problem. So we have 5 work package in our project, trying to answering the challenge of Europe's rail. We have done already the study of the past, while we are analyzing the demand side now and the supply side. These are the work package ongoing, and then it will be possible before the end of the project to go to work package 4 for the forecast of the actual availability gaps bottleneck, in order to understand what is the possibility and what is missing. And when I say missing, maybe from this webinar, we will heard also some possibilities of replacing some material with others, because what we will heard is so interesting, and maybe will have an impact in the change of the supply chain. And then at the end, we will deliver a final analysis. Just to give an example, 2 examples of what we are dealing with. One is additive manufacturing, certainly is already ongoing, is not something new, but it's a way to become a little bit more autonomous in the manufacturing of product, subsystem or system. And the other is composite. Certainly changing the substitution of material is another way to be more resilient. This, I think, ends the presentation on Leader 20. I invite you, as you have seen already in the chat, the connection, or you will see them. In the chat, you will see the way to reach us in order to have some contribution or to continue the discussion on this project. Thank you.
Yeah, thank you, Guido, for this interesting presentation of the LEADER 2030 project. And I will immediately hand over to my colleague Christian Zweiger from AC Styria. He has the task to introduce the first presenter. Christian.
Thank you, Lutz. Thank you for having me. Christian Zweiger, representative of AC Styria Mobility Cluster, one of the 80 clusters Lutz mentioned in his introduction. And I am proud and happy to introduce Christian Tipperetter of Schweizer Wood Solutions, a long-term, mostly R&D partner of ours concerning automotive. But as might be interesting for most of you, or so rail systems. And without further ado, I'd like to hand over to Christian, respectively. Lutz, thank you very much.
Good morning, everybody. From my side, also thanks to be here, and I'm glad to present our company, our technology to you all over Europe into the railway sector. So, Lutz, I think I can share my presentation. All right. Yes, perfect. It's now working. Yeah. Thanks everybody to be here and to present our technology. In the previous statements, we also mentioned some points regarding sustainability, and also I see some wordings also regarding wood as a raw material for new applications on. So this makes me very happy. Because we from Schweizer Group and traditional wood company, the Schweizer Group has in its mindset committed to find answers made out of wood. So we are a medium-sized group function coming from the parquet production, the parquet side. So Schweizer Parquet, Schweizer Wire Parquet. So we are quite good settled in Europe regarding the building sector and the flooring system in the building sectors. And I would say since, as Christian mentioned, since over 10 years, we are focusing to develop new sectors, new applications out of wood. So in this case, we developed the right side of our company path, for example, like the Schweizer Wood Solutions, and also now actually the Wood Vision Lab regarding finding new ways for developing and introduce solutions out of wood for the whole mobility sector. So we are working here on some national research projects in Austria and also international projects with our customers and our partners to figure out new solutions. We as group are working since 1831. From the traditional part, we are quite good in producing spools in parquet floors, from solid parquet floors up to 3 or third layer products, and especially also producing some stairs and so on and so on. So we have a quite range of knowledge regarding producing millions of square meters of parquets, if it's 2 layers or 3 layer parquets, and wooden products. So we are quite familiar with it. And with this knowledge, with this very huge backbone behind us, we now look very close what we can do with wood on a new way. Because in our mindset, the raw material is have a broad variety and a broad benefit, especially in Europe. Maybe one of you knows the CO2 storage of 1 cubic meters of wood is about 1 ton of CO2. So it's quite a big amount of when you use wood in applications to store the CO2 in the product, if it's in building, if it's a mobility part, or if it's something else. So, and especially when we look at our region here in Austria or even in Germany, Switzerland, also Italy, Spain, and the Scandinavian area or the Eastern area, everywhere in Europe, wood has is rich in the region. It's there. And we say it's the only or one of the only really renewable material with a very huge amount of material in our industry area here. So we see it as Europe. It's a quite big advantage for the European industry to use wood because we know what we can do with it. We know the industrialization part, and we have the material as a renewable material in our region here. So especially in Austria, 1 cubic meter of wood grows back every second in Austria. So it's ideal for using in circularity usages, can be good in reused or recycled in a cascade usage, and is also very good in sustainable lightweight material and lightweight solutions. So what I mean with this, I explain afterwards. We, as Schweizer Wood Solutions, you see here also actually an impressive amount from our side are committed to find answers out of wood, especially with the technology of pressing it in molds, pressing 3D layers or form parts out of veneers. So the challenge we have in Austria, we are quite in a big transformation phase. So when we look over Europe, we have now the chance to transform our businesses from fossil-based products, fossil-based solutions, if it's fuels, if it's materials or something else, into green business solutions, into circularity solutions, to recycle the products, to make also the energy usable from the sustainable part, but also the materials we have on a sustainable way here for new business drivens. And that's the reason why we are really focusing on our path to be an engineering and a manufacturing company. We say it for wooden hybrid components. Wooden hybrid components means we combine different wood species together to include a hybrid product, or we combine different materials together with wood, if it's some plastic materials or if it's also steel or something else. So we have technologies to combine also different materials with wood and to make the best out of each material. Therefore, we delivered for us an 5 phases process where we start with the customer on really and the engineering phase to find out new ways, to find out new solutions, and so on, and brings it to, I should say, to a producible part, to industrialize the part, and to produce it up to 1,000, 10,000, or 50,000 pieces every year. So in this way, we are certificated with, of course, ISO 9001, but also 27001, and so on, and also quite familiar with the certificates regarding burning issues and so on. So for us, it's really important to find new ways in designing with wood. Wood is a high-tech material. Wood at itself is an composite material and natural composite material out of cellulose, lignin, and hemicellulose. So I have a fiber with the cellulose and also a matrix material with lignin and a gluing system with the hemicellulose. So when we use this wood as design material to find new ways, have new ways regarding material databases to simulate this and bring this sustainable design solutions with the backbone of the data simulation part, brings it the new engineered solutions and gets out customized, optimized wooden composites for the whole industry. The main backbone behind this technology for us is the point of predictability. So in our research program, we were really close together with different partners from industry and also from the research point of view, if it's the Theograds, the Boca in Vienna, or the virtual vehicle in Graz, which are our simulation experts for us here in this case. And we find out the way to make the wood as a material predictable in finite element modeling system in our simulation programs. And with different use cases here shown as a side impact beam in a car, we delivered the whole system from the simulation models, the digital simulation point of a product. Here in this case, it's a side impact beam from a car, and make sure that this simulation part, this simulation programs and the material data behind them are in reality in the same function sent in the digital way. And that's for us the main game changer, that we are now able to bring in simulations, crash relevant simulations, crash relevant material data to new applications and to find here a way to optimize products which are in general are in steel profile and small high stiffness steel profile, and build up in natural based solutions. And that's the way why we always talking about we can produce lightweight parts out of wood. And that's also a little bit the explanation regarding the theory. Regarding when you look at some HB maps, if you compare here the density regarding the stiffness, mainly somebody of you is a technical expert and knows, of course, ceramics, metals, or composite materials are quite on the top level regarding the stiffnesses. And when you look at the natural part, the natural products, we have a quite broad variety regarding stiffness and density. But when you look at wood and the zero fiber deviation with a zero fiber angle, you see that wood here has a quite good performance regarding stiffness compared to density, because much lower density compared to other products. And when we now use this benefit of the zero fiber angle and quite a good performance from the stiffness point of view and also strength, and look at it on the detail level regarding which wooden species are here best in fit, I would say. You see that if you use birch or beech, are here quite good wood species regarding with this veneer technology. When we use thin veneer layers, quite good stiffnesses and tensile strength with a low density compared to other materials. And that's the reason why we are in main of our product developments 20, 10, 20, or sometimes up to 30% less in weight, so we can produce lightweight components compared to glass fiber reinforced composite, or also even to aluminium or magnesium and so on. So we are here on a quite good way to produce this in a 3D pressed parts, taking in some resin system. So this resin system for gluing the thin veneers can be polyurethane, can be formaldehyde-based systems or bio-based system, or even rubber-like or something else with a high flexibility. Mainly it depends on the function which customer or which product needs, especially when we look at the railway sector, which is a quite big focus for us. Of course, you have some limitations regarding burning issues and so on. But here are several resin systems which are working on a good way, and we have our certificates for some products in this case. For us, two digital processes are very important. On the one hand, the digital engineering process. So on the digital engineering phases to develop the specifications with the customer, the functions of each product, set up some designs, simulation models, FM simulations, taking in some optimization loops. On this stage, we often also brings in to this the linkage to the production process regarding costs. So we're quite familiar with setting up some cost perspective even in these optimization loops, and finalize some first final concepts, product concepts for first prototyping and so on. And especially on the stage of optimization and also in the design phase, for us is the production process very important. Also the production process from the raw material to the product, and especially to understand this function-oriented process control from the veneer layers, from the gluing system, from maybe some optimizing fiber mats, if we use sometimes viscose fiber or something like that, to enlarge the stiffness or the strength of the parts or the products, and to bring this digital fields, the digital product development and the digital process development together on an optimized way. With the main benefit, with one beside some technical benefits we can get with wood, also the benefit regarding CO2 storage. So unfortunately, this not only in German, but you see it in the picture. We have some from the wood car project, the research project, the side impact being from the car. We have here an bus stair entrance stair from an bus system. And here we substitute a steel part. On this way, we substitute a glass fiber reinforced part. And you see here on this part, we get less than 20% in weight, and much can reduce the CO2 equivalent up to 30%, or also the primary energy consumption for the production process up to 22%, with also to ensure that the needed stiffness, the needed energy for this part. So find the technical solutions which works. Also same on this entrance stair for the bus. We can reduce the weight up to 30%. Also CO2 equivalent reducing by 42%, and also the energy consumption in the production process. So this shows us, and there are a lot of other actual B2B parts. We are even not allowed to talk about it, especially for the mobility sector, but this shows us the point that with use of wood, you can get a high optimized part regarding the weight, and also optimize the CO2 equivalent in your whole product, in your company, and can store this CO2 in this with wood products. For us, in this case, it's very important to be responsible also regarding wood as a renewable resource. So we don't use any tropical woods or other things. We are really focusing on sustainable forest management companies here in all over Europe regarding the certificates FSC or also BFC, also different other certificates. And work very close together with Denkstadt in Vienna regarding sustainable reporting systems, and also defining the SDGs for our business content relation in the whole company. In general, when we look at the mass timber species and the main sourcing of the companies, we look at it in Austria and also in Germany, but here, for example, at Austria, the forests in general is changing from spruce to maybe more beech or also birch forest wooden species. And so this is the reason why we also look at quite here at this I would say old, but for the usages new wooden species regarding beech and birch for this veneer production fields. When we look now here, and hopefully this works, a small video only here on the manufacturing handmade working processes, how we use here thin veneer layers, cutting this thin veneer layers, similar to in carbon fiber production, where you have a pre-break. We have this thin veneer layers which are glued with different resin systems, and this glued thin layers are picked together. It depends on the whole simulation model what we need. It's similar to the carbon production. You also here have a different layup from 0, 90 or 45-degree layups with different pre-break stiffnesses, and that's here the same. Only with wooden veneer layers we use 1 millimeter in thickness or 1.5 millimeters, or if it's needed also thinner. Press it in a pressed mold. Depends on, of course, which glue you need, and then it's demolded, and then you have, as you see here, an complete pressed part in a 3D layer shape, as it is needed for our customer, for our purpose, and so on. Then it's quite similar to any other product. You need a milling system. Of course, we use here in 5-axis CNC milling system. Well, it's one of ours. We have several. Take out here the CNC, the mechanical preparation of the part, and work. Yeah, that should shows you and small, really on a base handcrafted program process. Of course, actually we are now in a quite bigger industrialized process, but to see in which way we are working. This is our sectors. We are really quite focusing actually on the railway sector with a really good partnership with companies, also on the automotive sector. And in the middle, we say there's performance parts, as dynamics part, as you see in a vertical wind turbine with the rotor blades out of wood, or also some wall box cases where we substitute some plastic materials. Now I would focus a little bit on our famous railway part we have. So here we're quite famous that we can talk a little bit about our part with the Siemens Mobility for the new high-speed train, the Velaro Novo. Here our partners Siemens work really quite time regarding this aerodynamic chassis part at the train, at the high-speed train. Make also an material comparison regarding also carbon as material, steel and aluminium as composite as material, also aluminium, and with our wooden parts. So we develop here some new fields with our wood parts. So we develop here a whole panel. It's a 3D pressed panel also with an system to enlarge the stiffness behind that. We optimized with this part the whole pressure in the whole energy consumption of the train. So when the train is driving up to 300 kilometers per hour, a lot of pressure comes up at the front part of this bogie. And so this wooden part has to cover this whole energy also. And with this part, and with this aerodynamic dynamic part, the drain can reduce the amount for energy consumption up to 15%. It's really quite high. And now we are really happy that this part we can hand over to a serious production and to figure out a lot of performance points with the wood. So for us, wood is not only the reason to use it because it's sustainable. It's one of the reasons, of course, but we can also make wooden parts with a very good performance. If it's the point with fire protection, we have a system to enables our wooden parts for our 7 HL2, for example, like this part. We take a lot of ballistic tests for the rail sector, for the outside chassis parts. We take a lot of testing regarding long-term behaviors, up to 30 years in usage at the train, a lot of climate change tested, and so on. Also regarding sustainable connection points with how to glue this metal connection points with wood and so on. And there we get a lot of knowledge, and we are happy that we can bring this knowledge we have inside also to other products, to other fields. Some parts also regarding a refurbishment of an company here in Austria with the project of the Steiermarkbahn, where they deliver the whole interior part here at the ceiling levels, also with fire protected wooden pieces and so on. As you see before, project regarding the helix wind turbine, the rotor blades. It's also at outside conditions, or a project with, as I mentioned, the wall box to substitute here and plastic a plastic part with a complete design cover out of wood, very thin, also with impressed veneer technology and so on. And this is also the last slide from us. So it's an important message for me is we could be a one-stop shop for lightweight wood-based materials, wood-based solutions for our customer. We have especially really the function, the customer requirements of a product, of a part in mind, define a path, define the solution to get and really manufacturing part up to thousands of pieces every year to fulfill the customer needs, the customer solutions, and hopefully quite happy to cooperate in future with more companies all over Europe. And from my side, I can say thank you. And if you have some questions, actually or afterwards, please don't hesitate to contact me, or also Lutz or Christian Zweigler from the ERCI. Thank you very much.
Yeah, thank you, Christian, very much for the interesting presentation. And for sure, there are questions, as you can see from this slide. The first one, what's new with the technology you use?
The new point is it's an old technology to press veneers in a mold. As you know it, maybe from stairs and so on. That's not so the new point. The new point is that we are now able to simulate it on a digital way to optimize the structure to the really thinnest layup and the really high performance layup regarding weightness and stiffnesses. So this is the newest point.
Yeah. Second one, wood as natural material has the behavior that it burns. How does it work with the regulations with the fire protection in the railway sector? And I guess it is nearly the same question than the last one. Maybe we can combine this question for the use of woods in the bus. Do you comply with fire and smoke norm?
We have here technology to prepare the veneer layers with materials and find special gluing system. Also, and combine this and with our certificates, we have actually for, I would say, 4 or 5 prototypes or products. On the best case, we reach on our 7 HL3 especially. So that's our main best certificate with a special composition of different prototypes are materials. And so we actually now are really quite familiar with this point to find ways to make the wood as product safe regarding fire regulations.
Yeah, coming from the next question, how do you make sure the wooden component produced is defect-free for efficient function? Is it possible that defects like cracks, pores, delaminations, etc., might lead to the failure of the component?
When we have some delaminations of the veneer layers, we solve with the, I would say, with the right pressure and the right gluing system to overcome this. And of course, for outside conditions, it's important to cover the wood to find a coating system, which is really, ensures the right function of the part. Of course, at outside with snow, with wet conditions, it's important to cover wood. And if some defects of a stone or something like that occurs, then we have technologies to shut these cracks and so on. But in special, the whole product is designed that no cracks or delaminations can occur regarding the right coating, or sometimes also with some stiffness optimization regarding fiber mats and so on.
Yeah, we have some more questions. I'm coming to a general one, not to this presenter. As a general question, maybe we could discuss it afterward. As a maintainer and operator of railways, we focus on the end of life stage of trains rather than their construction. What best practices or innovative approaches would you recommend to ensure the decommissioning process is aligned with circular economy principles? Yeah. Especially how we can maximize material recovery, reuse, or recycling while minimizing environmental impact. Have you got an answer on this question?
So it's not directly to me as a presenter, or
Maybe you have an answer. So you have the first right to answer, and then for sure it could be discussed. Maybe there are also some attendees which might answer by using the chat function during the second presentation. But if you have an answer, please proceed.
for our point of view, we have the end of life stage in mind also at the beginning of designing a product. So when we design best case the product with its function, then we design it that it's usable in a cascade wood usage, in a circularity, in a reuse step. For example, we designed it that it could be recycled in how it's called, it's in recycled wooden parts for also the particle board industry, for example. If it's then milled up for small fibers, then the particle board industry can use it for new particle boards, use this also several times. So for us, it's important that our solutions are working within this cascade wood usages and not to burn it after the first usage, because that's not our main way, I would say.
Yeah, coming to the next question, do you have invasive species? If so, have you considered for testing them as innovative materials?
Some wooden species are not here quite familiar in Europe. We have some test samples also regarding this. So we have here the material on the research point of view, also on as, how should I say, on our whole overview. Actually not in a usage in a product, but we have it in mind and have a look also on it.
Yeah, next one, are the wood solutions for reducing the weight of a product in the railway sector, which are the saved percentage?
Yeah, we can only look at the single piece or the product, and when we look at the product level, we can reduce it up to 10-20%. Of course, it depends on how much of this product technology you use on your whole railway picture, I would say, and the whole vehicle. But in general, when we substitute, for example, aluminium or also steel, we can make an weight reduction up to this 20%.
So 2 more questions. How do you face harsh environment, temperatures, acid products, and so on of a railway line for products external to a train?
Temperature is not so the problem for wood. Maybe compared to steel, you have an enlargement of steel or all other metals regarding the temperature as a function. Wood has no problem with the temperature, I would say up to 180, 200 degrees. So they have no thermal extension with wood regarding metals. So this is not the problem. The problem for wood, or the point with wood, is also only, or one point is the moisture, and for the moisture also some other fluids. We have to protect the wood with some with the coating systems and the coating behavior, and there we have I think we have actually 50 or 70 different coating systems in our looking field actually, and take the right one of our system for the right usage with the wood.
Yeah, looking at the first question of this slide, I'm not sure whether we have already answered this question. Is the Siemens cover patented, or could this be used by other manufacturers, bogie manufacturers?
This we have discussed with Siemens.
Yeah, all right. So now the last question. What about hazardous substances according REACH and RERISL? Do you comply with new requirement of formaldehyde restriction for wood-based articles?
Actually, we have here with the formaldehyde restriction not so on in the point, because we use some polyurethane gluing systems especially, and not formaldehyde based system, especially for the railway sector. But when we in general, from the wooden technology point of view, the formaldehyde restrictions is mainly a point with the particle board, because there the amount of glue is much more higher than here when we use our veneer technology. But if you have detailed questions regarding this, we can discuss later on.
Yeah, I think as you wrote on the last slide, also your contact data, I'm assuming that we will provide your contact data to all the participants of the webinar, so that you have also afterwards a chance to contact Christian. Thank you for this interesting presentation, for the answer to all of these questions. And coming back to the next presenter, and it's a pleasure for me to introduce to you Miguel. And
hello.
Yeah, hello, Miguel. Miguel is a chemist and a chemical engineer with over 18 years of experience in the rubber industry. He began his career designing rubber compounds for the tire market before transitioning to the design of structural rubber components. Throughout his career, Miguel has gained extensive expertise in material science and engineering, contributing to innovative solutions in various sectors that utilize rubber-based technologies. Miguel, the floor is yours.
Okay. Thank you, Lutz, and welcome everybody to this speech. I'm going to share with you the presentation.
Only have to switch on the presentation mode, and then it's fine.
Yeah, okay. Thank you very much. And as I told you, thank you and welcome to this explanation of how we can recycle rubber from end-of-life tires as a resilient components in railway infrastructure. Today, we will discuss innovative and sustainable solutions that can help the railway industry to reduce its environmental impact while enhancing the performance of critical infrastructure components. This class will provide an overview of the importance of sustainability in the railway sector and how materials like recycled rubber can be used to improve the resilience and longevity of the railway systems. Well, as a global awareness of environmental issues grows, industries across the world, including transportation, are seeking ways to reduce their carbon footprint and optimize resources use. The railway industry, which is a vital part of the global transportation, faces challenges related to aging infrastructure, increasing demands for capacity and sustainability. Recycled rubber, particularly from end-of-life tires, is one of such material that can contribute to meet this challenge. It offers enhanced performance properties such as vibration damping, noise reduction, and increased durability, which are essential for maintaining and improving railway systems. This is important because the key point with this material is that this vibration damping and noise reduction. It's very important, and we are going to discuss this largely during the speech. Okay, a brief introduction about rubber recycling. Recycled rubber refers to rubber materials that have been collected, processed, and repurposed for new applications, typically once they are no longer suitable for original use. The most significant source of recycled rubber is end-of-life tires. This means that approximately 3 million tons of used tires are collected around Europe, European Union, according to the data from Eurostat. For these 3 million tons, 50% are recycled. That means that we have 1.5 million tons of tires that are not recycling nowadays in the European Union. We are talking about a lot of material that has a very big, big problem in terms of waste, because chemically the end-of-life tires is a very, very unpleasant material because there is no chemical back reaction. So you have to try to find how to ensure that this end-of-life tire can be recycled. Now, European Union is working to increase this 50% of recycled, this rate of recycled rubbers, because these rubbers are incorporated in asphalts, in construction materials, and of course in railway infrastructure. The remaining tires either used for energy recovery. This is important. We burn a lot of tires in Europe. And finally, other part of these tires are sent to landfills, although the latter is increasingly being minimized due to the stricter environmental reduction. That means that from these 3 million tons of tires, we can recycle 1.5 at this moment. And other 1.5 million, one part is burned for producing energy, mainly in factories for concrete, and the other part is sent directly it's not recycled, it's sent to the nature. So this is the way we have to work to reduce to zero this kind of sending. The key advantage of using recycled rubber from tires is that it's a very, very important material because of the shock absorption, noise reduction, and vibration control. The key point in this speech will be that we are going to take profit of these properties of the raw material, because the tires are built with the very high standard rubber compound. So we are going to take advantage of this very good compound, and we are going to transfer these properties to the railway, in this case, to the railway applications. Okay. By adopting recycled rubber from industry can take a significant step towards recycling its carbon footprint. This is important because in comparison to other materials for resilient applications in the railway, recycled rubbers is zero carbon print food carbon print. So it's important to take in mind this important point. How in this slide you can see that how is the life cycle of a tire. The tire is produced in the tire factories, and then after the consumption there are two different kinds of tires. The first one is the ones that can be converted again in tires by using the tire itself or by retreating or recovering tires. And the second group is the tires that can be converted in new tires. So in this case, we have different options. We have material reuse, we have material recycling, energy recovery, and final disposal. In the right side, you can see a tire. Tire is made basically in rubber. You will see the rates in the next slide. But you can see that there are steel, nylon, and rubber. And those are the rates in the right side. Those are the rates of each material in the tire. In blue one is passenger car, and in red one truck car tire, and in yellow off-road tires. You can see that the ratios are from 50% more or less of rubber, 22% carbon black. Carbon black is kind of reinforced filler. Then you have metal. Metal is 25 to 12%. Textile and other additives. I have to say that the tires from truck cars are mainly used for this kind of application in anti-vibration for railway because of the amount of rubber regarding the other materials in the composition. So in the right side, you can see how we recycle, how we can convert the tire in a recycling material. First of all, we collect the tires, then we cut the tires to big pieces. Those big pieces could send directly to energy production, but then if we keep on with the process, we have a shredding step in which we reduce the size of the rubber pieces, then an electromagnetic separation where we separate the steel from the rubber parts and the textile. The next step is the pulverization and separation, where we separate the textile inserts, and finally grinding and the chemical and thermal treatments. So after this chart, we can obtain the granulates 100% clean of other materials. Then textile inserts and steel parts will be recycled by other processes. Well, now we are going to focus our speech in resilience against vibrations. Why we are talking about rubber? Because rubber in the railway sector is a material that can be used to reduce vibrations. Okay. Railway vibrations are an inherent phenomenon in rail transport, especially when trains operate at high speeds or when infrastructure is subjected to intensive use. These vibrations can have various negative effects on infrastructure, safety, and passenger comfort. Resilience against this vibration involves designing, maintaining, and operating railway systems in ways that minimize, mitigate, and adapt to the effects of vibrations, ensuring long-term functionality and reducing associated risk. What I mean is that resilience in terms of vibration attenuation will be very important in our speech, because with the use of recycled rubber materials, we can reduce this vibration and we can give more comfort, more long life, and structural to avoid the structural damages in the infrastructure. So the vibrations, is a key point in this speech, are very harmful in terms of infrastructure, for the railway applications. It's not a mean of, okay, it's going to affect the buildings itself, but mainly it affects the comfort from the passengers and from the people that lives near the railway lines. So it's interesting that we have the vibrations generated by passing trains affect various parts of the railway structure. First of all is the track wear. Okay, constant vibrations contribute to wear and tear the tracks. I want to say that vibrations are not good for the tracks because they are supporting, but they are withdrawing a lot of very short but sometimes very strong efforts. So it's important to control these efforts. Second one, structural deformations. Structural deformations, vibration when the trains passes. They have a lot of deformation that mainly affects bridge, tunnels, and buildings. It's not an effect that can make the bridge or the tunnels or buildings collapse, but you have to keep in mind these deformations because they affect to the performance of the infrastructure. Then, and very important, is the impact in nearby buildings. Of course, when you live near a railway line, it's not comfortable when the train passes. So governments, operators should reduce the vibrations and the noise generated by the trains passing by. And finally, of course, the passenger comfort and safety. You will travel more comfortably if you have a good resilience in the railway lines. Okay. Then how we can face these vibrations? Okay. First of all, in terms of design and materials. Design and materials is a key point. You have to design the infrastructure, and you have to get the resilient track. All the people involved in designing know that resilience is very important. So they try to design the tracks according to reduce the vibrations. But sometimes it's not easy only by design. So you need to add vibration isolation, for example, rail pads or damping systems. Here is where Caucho Verdú is going to show you that we can reduce the vibration that the designers can't do with the design of the structure. And finally, a flexible structure. So we have to monitor and control the vibrations. It's important that for improving this attenuation, we must put vibration sensors and predictive model to try to avoid the vibration in the structure. Then, which kind of vibration reduction technology we have? We have, in addition, other technologies to reduce vibration, but it's not the issue in this presentation, but like active vibration reduction systems and improved wheels and tires. So we can reduce vibration not only with the isolation, but designing the track and designing the vehicles. And finally, predictive and adaptive maintenance. All the governments, all the operators should have a preventive maintenance. If you build a new railway line, you should maintain this line in order to prevent the improvement of vibration and the uncomfortability of the people, passengers and people who lives around the line. Well, which are the benefits of improving, of reducing vibrations in railway? First of all, we increase the lifespan. We increase the life, we extend the infrastructure life, and reduces costs. That means that at the beginning it's more expensive to implement these strategies of resilience, but with the years it will be cheaper. You have to, all the operators and governments should check this, should have this in mind, because it's not only the cost of the building the infrastructure, it's the cost of the maintenance. So it's important, this point. Second one is the safety. If you have a line, a tramway line, a railway in good conditions with less vibration, you minimize risk of failures and accidents, of course. Then the passenger comfort is important. When you travel by train, you want to be relaxed and you want to a comfortable journey. So it's important in this field. And finally, environmental impacts. The noise and vibrations are very unpleasant for the people who lives around the lines, and of course the around and traveling in the railway. So as a conclusion, resilience strategies ensure long-term functionality, safety, and sustainability of railway infrastructure against vibration. So this will be the key point in this presentation, because we are going to focus on how we can reduce the vibration in the railway applications by using rubber materials from end-of-life tires. So now we are going to focus in our material, the recycled rubber. Recycled rubber is a very exciting product, because as I told you before, recycling rubber from tires is a very good rubber. When the producers of tires like Michelin, Goodyear, Pirelli, they use the highest standards in the production of the rubber compounds. So then when the tire its life is finished, we will take profit of these high properties of this compound. So we are going to take this compound, we're going to clean the compound from steel and from textile, and we are going to use the very good properties of this compound to avoid vibration from railway. So recycled rubber can be get from three different ways. Granulated rubber is that when we use directly the granulate from the mill, we can add to the, for example, to the ballast. By adding granulate small pieces of rubber in the ballast, we reduce the vibration and we can reduce the maintenance of the ballast. Second one is the composite made of granulate rubber with a binder. This is the product where Verdú is a leader in the market. So we are going to focus the presentation in this product. We use granulates and we bind them with an adhesive, resin or bitumen, and then we produce pieces like sheets or like rolls to avoid vibration in the railway sector. And finally, we can get powder or the vulcanized rubber. The vulcanized means that the rubber we get by this method could be incorporated in new rubber compounds. But at this moment, the technology is not enough to ensure the properties of the rubber before the vulcanization process. So at this moment, we can use the vulcanized rubber, but not in very demanding pieces, okay? So now we are going to focus in how the composite material could help the railway designers to get better comfort. This is what I told you before, the pieces we can get from the grinding material. There are different sizes, different composition, but quickly, the first one, A, is when you cut the tire, you get some rubber with pieces of textile. Second one is the granulate. granulate is clean of steel and textile. C is the powder can be added to other rubber compounds. And finally, D is the how to say, the chip. It's like a long and very thick material that can be used in the composites to get more tear resistance to the product. So this is the key point in the composite made of recycled rubber. Recycled rubber is mixed with a resin and then is pressed, and the structure, the microstructure of the product in the right side, you can see that there are a lot of air spaces, air cavities. Those air cavities are the key point of the performing of this material. Air-filled cavities creates a honeycomb structure. It's like, okay, I have different elastic spheres that can be deformed, and this space can be deformed with the deformation of the rubber. So this is crucial for vibration damping and shock absorption. Of course, rubber granulates maintain elasticity. So you can imagine a lot of spheres, very elastic spheres with very good properties, and in the middle some air cavities. So this is the way how the rubber composite is going to work. So the properties of the composite material, first one, as I told you, vibration damping. The air-filled cavities and the elastic nature of the composite allow it to effectively dampen vibration. This is especially valuable in railway applications where the constant movement of trains generate vibrations that can cause wear and tear on both the track and the surrounding infrastructure. The composite absorbs these vibrations. So this is the product we are going to use in the vibration. Shock absorptions, the same. The combination of rubber granulates and binder provide excellent shock absorbing properties. When forces such an impact from the passing train are applied, the material absorbs and disperses the energy. This is important because we are not only avoiding vibrations, but we are avoiding shock against the ballast, for example. So by using this material under the ballast or under the slipper, we can reduce the vibrations in the structure. It's important, vibrations and shock absorption, and you are going to increase the life of the infrastructure. Then the durability, it's shown that the durability of rubber compounds, rubber material like this, is higher than other materials, other resilient materials. You will see at the end of the presentation. Then noise reduction is a key point. We're going to reduce noise by the use of these applications. And thermal stability. Rubber compound is very stable in the temperatures that we are going to use it, from -20 or -30 to 40 degrees. This is the material that will be ideal material for railway system, offering an exceptional resilience, durability, and sustainability. So we're going to show you what kind of products we can produce to avoid vibrations and mitigate noise and shock absorbers. First of all is under ballast mat, slab track mats, embedded systems, and the slipper pads. First of all, the rail pads. Rail pads is the black sheet between the rail and the slipper, and the function is placed between the rail and the slipper and distribute the weight of the train. This is the first barrier to avoid vibration from the train. Second one is they are anti-vibration mats. We have two different kinds of anti-vibration mats. First of all is under ballast mat, and the ballast mat is the mat that it's installed below and under the ballast in the ballasted systems. Okay, and as you can see in the picture in blue color, we put this mat to stabilize the track, prevent ballast displacement, and of course reduce vibrations. This is some pictures of how this material can be installed below the ballast. So you can see that the ballast is protected and the ballast is confined. When the ballast is confined, this protects the ballast. And the format is in shape of sheets of rolls. Then the second one is the slab track mats. The slab track mats is the same than the under ballast mat, but it's installed below the track system, the ballastless track system. You can see the blue one below the. It puts ballast. It's not ballast. It's a concrete plug. So we can install this product below the track in the ballastless tracks. It's the same. Avoid vibrations, protects concrete, and improves passenger comfort. And it's important because sometimes it's used to reduce the thickness of the concrete works. You can, if you work with this kind of material that itself is green, you can reduce the civil works and you can reduce the thickness of the concrete sheet. So sometimes designers ask us to help them to design new track, reducing the thickness of the concrete, because at the end will be better to use that. Will be greener in terms of using recycled materials and will be greener in terms of reducing the civil works in this project. The third one are the underslipper pads. Underslipper pads is a kind of, it's a product that is placed under the slippers. Under the slippers, we can say that is the second barrier to reduce the vibration. First one was the rail pad. Second one is the underslipper pad. When you use this kind of material, you can reduce the shock absorption. It's important because when the train passes, the slipper shocks against the ballast. So you can break the balance because concrete is shocking against stones. So by using this kind of products, you get short absorption and you reduce the forces, the direct forces from concrete to ballast. So by using these products, you can get longer life in the infrastructure, and you can reduce the maintenance cost of the railway. And finally, we have the other resilient element is the embedded rail system. This kind of product is used mainly in tramway, metro, and light trains when the rail is incorporated in the track. So we use a kind of covering of recycled rubber that in this case will be the first and only barrier from the train to the ground. So by using this product, we are going to reduce the vibration mainly in urban areas because this is mainly for metro and tramway. So it's important. Then a case of study. A case of study, we are going to talk about a real case in Spain. In Spain, you know, Spain is the second largest high-speed railway in the world. So the Spanish, we are very concerned about the vibrations, about the comfort of our high-speed train. So in this case, this is a new line. This is it's going to be finished in the next year. So they had a problem because the line passes near a city called Navalmoral de la Mata. In this case, the railway passes so near at a very high speed, 290 kilometers per hour. So they decided to improve the countermeasures to avoid vibration. In this case, they needed a decrease of vibration of 20 decibels at 63 Hz. The problem here is that, okay, that using one single material is not enough to reduce that, because there are some underpasses. So we studied with them the problem, and we advised them to use a double barrier of 20 millimeters, in total 40 millimeters of anti-vibration thickness, anti-vibration mat. So in this case, by using this material, we could reduce the vibrations, the noise, more than 20 decibels at the design speed. So this is a case of study, because by using, it's real, by using recycled rubber, we can get a very good result in terms of attenuation. And then I'm going to finish with the challenges and considerations of these materials. If we compare this material, recycled rubber, if we compare with other materials like PU foams or rock wool, we have better properties in terms of elasticity, shock absorptions, and durability. It's proof, because you can see all the publications, all the technical studies, that recycled rubber is better than other materials. So,
may I ask you to finish your presentation?
Yes. Only half a minute. So if you compare our product, we know that some people don't want recycled rubber, but if you compare with other products, our material is better in those terms. It's true that it's less performance with the fire resistance. Okay, that's all. Thank you, Lutz.
Thank you, Miguel, for this interesting presentation. I guess we have a lot of questions as a result of your presentation, and I continue to share my screen. And okay. I try to start with the third questions because the first ones are pre-prepared, and the third one came directly from the audience. How do you ensure the reliability of vibration sensors? I mean, how can we know how much small vibration amplitude could be detected? Do you follow the probability of detection concept?
Well, in this case, we know that the railway is going to cause vibrations. Okay, so we are fighting against this vibration. We are not going to eliminate them 100%. So in this case, vibration sensors are important, but we have to ensure that the reduction is a real fact. So in this case, maybe I didn't understand the question, but I have to tell you that it's real that we can decrease. Of course, we can decrease 100% the vibration, but it can be measured if you measure the same railway with and without the countermeasure, with or without the resilient elements.
Yeah, I guess we will have the opportunity to share the contact data with that person as asked the question, and he will have the chance to get in direct contact to you. And come to the second one. Do you know which is the percentage recycled content in your parts?
Well, it's difficult to know, because this is not a clear information. But I have to tell you that in Europe, we have, from Eurostat, we have 3 million tons of recycled tires. From these 3 millions, half of them are recycled, are converted in granulates and incorporated in other products. But we don't know how much of this ratio can be incorporated in the railway application, because it's not an information that we can get easily, because the producers of granulates, they sell to other clients, and the traceability is not possible in this case.
Yeah, I kindly ask you for short answers to the last two questions.
Okay.
Building recycled rubber under ballast is possible with the construction of a new railway tracks. However, can you use these rubber products under the already existing tracks?
No, unfortunately, you have to change the ballast and to put a
Yeah,
new.
I would say that was a very short answer. No, I think you said it is no emissions. It is verified with an LCA analysis. Do you have environmental product declaration?
Yes, we have an environmental product declaration by AENOR, so it's clear that it's zero emissions because you are checking a product with a negative carbon footprint. And then one thing that I didn't say is that at the end of the life of the mat or the other product, you can recycle this material to others again.
Yeah, shortly coming back to the first two questions, I'm very sure that Miguel is able to answer these questions when you directly contact him, because we have no time for the moment to get deeper into these two questions. And thank you, Miguel, for this interesting presentation. For sure, one question is anytime will be the presentations available. I guess I will contact both of you, Christian and you, to send me a final presentation as in PDF in order to forward it to the participants. For the participants, it would be very good when you follow our short feedback questionnaire, which give us some information in order to improve the webinars, to handle with new topics you suggest, and so on. So it takes only 2 minutes to answer these 5 or 6 very short questions, and please let us know. And if you are interested by yourself to be part of the webinar as a presenter, please let us know too. So most of the webinars are recorded, and you will find the recordings of the webinar at the YouTube platform of the STARS project, and give us some days time to finish the recording and cut the recording, and so it will be available, I would say, by the end of the week or early next week. So the next webinar is on how to solve the stagnant rail freight share in the EU. The reservation link is already available, and you see it is not in 2024, it is already in 2025. That means that was the last ERCI webinar in 2024. It was one of 13 ERCI webinars this year. And I will conclude with some news from the ERCI network. I already mentioned that is the possibility that you can apply to the next year's ERCI Innovation Awards by contacting your regional ERCI member cluster, and they will make a regional pre-selection, and in the end they will nominate their 3 best applications to the European stage. So the application phase starts normally in spring 2025. Maybe some clusters say, oh, we can immediately start. So get in contact with your clusters and look what are the possibilities for your application. Then some information on the Horizon Europe framework program. There is the most interesting status for rail topics and for mobility topics are the cluster 5 on climate, energy, and mobility. The new calls for the working programs are not published so far, but there are a draft version, and you will find the current version of the draft of the working program 2025 for cluster 5 by following the link indicated in the chat. And the expected timeline is the following. We will have a procedure for consultation of stakeholders will run until the end of this year. Then will be an inter-service consultation in January, February next year. The draft version of the working program expected to be adopted by the program committee in March 25, and finally adoption of this working program will probably take place in April 2025. So we keep you informed, and if you are interested to contribute in Horizon Europe, please contact ERCI or contact our national or regional cluster points, clusters, in order to indicate your interest. And we are pleased to support you in finding the right consortium. So, yeah, one other opportunity is to participate in the experience of the already finished success project. It was on supporting European SMEs in successfully applying to public procurements in USA, Canada, and Norway. If you are interested in these three markets, there is a possibility to contact Irina, Amelie, or Gerazi to receive some further information. So we are at the end of this webinar, and thank you very much for your participation. Yeah, have a nice Christmas season. As I said, it's the last webinar this year, and you can only give a gift from Santa Claus if you answer our short feedback questionnaire. So you are already warmly invited to take this opportunity to indicate your answers in this short questionnaire. Thank you very much for participation, and see you soon. Have a nice day and a nice Christmas time. Bye-bye.